Assalamu alaikum and welcome to Cambridge Chemistry channel with sarwatahmed. Be sure to like the video and subscribe it. Really helps the channel to grow. Today I will discuss the past paper questions of electrochemistry. So let's start. What do you understand by the term standard electrode potential? When electrode potentials are measured under standard conditions, it is known as electrode potentials. Electrode potential of electrode system measured under standard condition are called standard electrode potential. Standard electrode potential. Represented with E. And you know that the standard conditions are temperature should be 298 Kelvin, concentration 1 mole per dm cube, and pressure is kilopascal, which is equal to 1 atmospheric pressure. And you know that the electrode system is the half cell consists of a species in contact with its reduced form in aqueous solution. For example, this is metal electrode system, aqueous, this is reduced form. This is one of the electrode system and this is metal electrode system. Reduced form and this is oxidized form. So next question is the following cell was set up between copper electrode and an unknown metal electrode M2 positive to MS. The standard cell potential was found to be 0.76 and the copper foil was the positive electrode. So let's say this is the unknown metal XM2 positive or M with copper foil, and you know when if the standard cell potential was found to be 0.76. Use the data booklet to calculate the standard electrode potential of the M2 positive and M system. So this is the formula to calculate E cell. From the data booklet, you know that E right side minus of the cell you can write down E reduced form or E right side, E reduced, or forward side of the reaction, or minus a cell of oxidized form, or left side of the reaction. So the question shows the standard cell potential was found to be 0.76, and the copper foil was the positive electrode. So next question, draw an arrow over the voltmeter symbol in the above diagram to show the direction of electron flow through the voltmeter. So it is more positive, and this is unknown metals which would be highly reactive, so electron flow from left to right. So this is electron flow left to right. Predict the outcome of the following situation. Describe what you might see. Write ionic equation for any reaction that occur. A rod of metal M is dipped into copper a solution of 1 mole per dm cube of copper to sulfate. So when any highly reactive metal dipped in the solution 1 mole per dm cube of copper sulfate solution, so the observation would be pink copper will be formed and blue solution fades. So the question should be like Cu2 positive metal rod M to form copper solid and plus M2 positive. Next part is dilute sulfuric acid is added to beaker containing a powdered sample of metal M. Powdered sample of metal M. You know that because direction of electron flow is from left to right, so this metal would be the highly reactive than copper. So when we add dilute sulfuric acid is added to the beaker containing a powdered sample of metal, hydrogen gas is evolved. The reaction is ionic equation for this reaction is M plus, which is unknown metal 2H positive, to form M2 positive plus H2. So in this question he asked about how to predict the metal M, that why current is flowing from left to right, because over here standard cell potential was given, which is 0.76 volt, and we will calculate like this because standard electrode potential of copper is 0.34, so 0.34 minus 0.76 is equal to 0.42. So this will be the electrode potential of unknown metal. So it means this is negative value, so this will be more reactive metal than the copper, so that's why reaction flow from left to right. So next question is because of increased scarcity, cheaper copper because of its increased scarcity, the cheaper copper ornaments are no longer made from the solid metal but from iron that has been copper plated. Complete the following diagram showing the setup for a copper electroplating process. Show clearly the polarity of the power source and suggest a suitable electric current, suitable electrolyte. So copper ornaments are no longer made the solid but from iron that has been copper plated. So when copper plated, the electrolyte would be the copper sulfate CuSO4, and object to be plated, and this is the anode. Anode is made up of copper rod, and this is object to be plated. A current of 0.500 ampere is passed through the electroplating cell. Calculate the time required to deposit a mass of 0.500 gram of copper on the ornament. First, let's find out mole of copper is equal to 0.500 divided by 63.5, which is equal to 7.87 into 10 raised per minus 3. And we know that the copper moles of electron would be Cu solid. These are the reaction at anode. Cu 2 positive plus 2 electron. This is anode reaction and this is cathode reaction. Copper aqueous plus 2 electron to form copper solid. So 2 moles of electrons are required to deposit copper on the object. So if we know that the 2 electrons, so mole of electron would be is equal to 2 into 7.87 into 10 raised per minus 3. And number of Coulomb charge is equal to, this is constant, F is equal to LE. We can calculate by using this expression. F is equal to LE, where L is Avogadro number 6.02 into 10 raised per 23, and E is the electron charge 1.9 into 10 raised per 2, 1.6, sorry, this is 1. By using Coulomb, F is equal to LE, where L is the Avogadro number, which is equal to 6.02 into 10 raised per 23, and E is the electron charge. It is equal to 1.6 into 10 raised per 2 minus 19. So this is equal to, this is calculated experimentally, which is equal to 96,500 Coulomb. So number of Coulomb is equal to 96,500 Coulomb, and which this is mole of electron would be equal to 1.57 into 10 raised per 2. So number of Coulomb is equal to into 1.57 into 10 raised per 2, which is equal to 17. And we know that Q is equal to IT, and we can calculate time when we have current 0.500 ampere. So time is equal to I over T. time is equal to I over Q. So which is equal to 1517. Sorry, Q is equal to this is we will calculate with the help of Q is equal to IT, and we have to calculate time, so that is equal to Q over I. So Q is equal to 1517 coulomb divided by 0.500, which is equal to 34 seconds.